Very good morning, everyone. My name is Amrita Mohan, and I'm serving as Assistant Professor at Ashoka Institute of Technology and Management, Pahadia, Varanasi, India. And today I'm here to deliver my talk on the topic Deep Learning for Landslide Detection. Uh, Now let's begin with the topic. This is the outline of my presentation, which I'm going to discuss today. Now, let's start with the introduction to artificial intelligence. First, we know that artificial intelligence, machine learning, and deep learning are interconnected together. The machine learning is the subset of artificial intelligence, and as we can see in the figure that deep learning is also the subset of machine learning. Now, first we need to proceed with the term intelligence. What is the meaning of the term intelligence? And the term intelligence means the ability by which we can make some information and make some decision based on that information. And from this term intelligence, artificial intelligence terms, artificial intelligence came into the picture. Now, therefore, we can say that artificial intelligence is an ability for a computer or machine to make information so that we can use those information to make any kind of decisions. And as we can see in the figure that machine learning is a subset of uh, artificial intelligence in which we focus on teaching the machine how machine learns from data without being explicitly programmed, and then we move to the deep learning. In As we know that deep learning is also the subset of machine learning, as we can visualize in the figure also. And AI and in AI, in which we focus on the use of neural network for automatic extraction of information and features from the raw data. And those pattern or those information or features of the data can be used to inform the learning task and make decisions. That is known as deep learning. Now, with deep learning, we have some unprecedented results in the variety of fields like speech recognition, computer vision task, time series forecasting, optical character recognition, spam filtering, search engines, autonomous driving, and we have more and remote sensing. And we have more tools like GPU, that is graphical processing unit, that helps to handle the graphic related work, that is graphics, effects and videos. And nowadays we have big data sets, and as we know that data are everywhere, and some open source softwares are also available, that is TensorFlow and Keras. And these are the libraries that are provided by the Google, and they are freely available, so anybody can use it. And all these tools are adding extra capabilities to the deep learning task. Now, in today's lecture, the main focus of the main focus in on is that the application of deep learning techniques or deep learning tools on the remote sensing images. Now, since we have a number of applications of deep learning, but today I am going to discuss about the application in remote sensing domain. As it is visible in figure 3 and figure 4, that deep learning techniques can be used for object detection and in land use land cover classifications also. The In the object detection task, the objects are identified, and basically it is just an example of image classification, and that covers the land use and land use land cover classification also. And figure 3 and figure 4 are the examples of some remote sensing images where uh, deep learning technique has been applied to performing the object detection and for the image classification on the images. Now, I am going to in the next slide I am going to discuss about the basic introduction of the landslide, that is followed by the major key factors involved in the process of landslide. Basically, landslide is the downward movement of the soil or the rock, or we can say debris or earth, under the influence of gravity. And the causes of landslides includes both human and natural causes. The consequences involves loss of life, infrastructure destruction, loss of land and natural resources. The direct effect of landslides involves road blockage, sudden failure of supply lines like telecommunication, electricity and water supply connections. The indirect effect of landslide includes reduced property value, loss in the productivity of land and agriculture. There are some major key factors that are involved in the landslide phenomena. That includes the type of material, the geomorphic attributes, geometrical attributes, and the speed of movement, the triggering mechanism, etc. Now, in the next slide, uh, I'm going to explain. I'm going to discuss why I am motivated to pursue my research in this domain. The main motivation behind this research is basically the occurrence of chain of landslide events that are frequently occurring in different parts of the country, and that causes loss of infrastructure and people lives. In India, more than 12% of the territory is a landslide prone area, and it kills around 300 people per year. Since assessment of losses caused due to landslide is difficult in hilly areas, and it may go unnoticed in the terrains where there is no population, that leading to missing of updated national scale landslide inventory. And the since the updated landslide inventory is important for the development of innovative landslide early warning system in landslide prone areas, and without inventory it is not possible to design the early warning system for landslides. So currently deep learning techniques and tools are revolutionizing, and there is need to develop the new inventive AI tools for automatic identification of complex landslide features. And in India, there are several agencies like Central Road Research Institute, Central Building Research Institute, Vadi Institute of Himalayan Geology, that have, and they are carrying out research in this domain to minimize the landslide induced accidents and providing the solutions. Now, this slide represents the national and international landslide status around the globe. The In figure 7 we can see that global landslide status reported by NASA. In this figure, the light blue dot represents the landslide area. Further, it can be utilized to improve the understanding of location and that and causes this destructive and the causes of this destructive hazard. Now, in figure 8, that represents the national landslide status reported by Geological Survey of India, and GSI is the basically nodal body for landslide in the country, and the hazardous areas are ranging between very high to very low, as we can see in a red color. That red color indicates very high hazard, that covering some portions of Indian subcontinent, including Arunachal Pradesh, Sikkim, and major portions of Himachal Pradesh. Now, this is the basically state-wise distribution of landslides, and the major hotspot regions of landslides or major regions in India that are highly affected by landslides. The major landslide occurrence will take place in Uttarakhand, covering total of 51% of the total landslide area, and approximately 15% is covered by the West Bengal, 13% by the Himachal Pradesh, and 10% by Sikkim. And the Western Ghats are also affected by landslide that includes Maharashtra, Goa, Karnataka, Kerala, and Tamil Nadu. Now, recently there are several studies are going on for that are focusing on the landslide detection approaches, and the current landslide detection approach involves these three methods. The first one is pixel based method, second one is object based method, and third one is deep learning based method. In pixel based method, it is used to for the extraction of low level features where the image is classified on the basis of spectral information, where the pixels in the overlapping region will be misclassified and due to the confusion among the classes. And now we come to the next part, that is object based method. In the object based method, it is also termed as object oriented classification, and in this process it involves the categorization of pixels that is based on the spectral characteristics and the shape, texture, and spatial relationship among the surrounding pixels. Now the deep learning methods. In deep learning method, it use multiple neural network layer to progressively extract the higher level features from the input. Now, why deep learning technique is important, and what is the need for deep learning technique for landslide detection? Since landslides occurring in hilly areas are causing considerable damage to infrastructure as well as people loss. So the highest landslide hazard prone areas in India includes northwest Himalayan region, Himachal Pradesh, and Jammu and Kashmir and Uttarakhand. Therefore, we need to have a novel method for automated landslide detection by using crowdsourced images that are targeting the hilly areas and acquired by UAVs by using deep learning techniques that has been proposed in this work. The major objective of this research is to investigate the transferability of the pre-trained network to the alternative types of images, along with the utilization of the concept of transfer learning approach with the limited set of training data set and achieving good results. And the second objective is to perform the object detection task on the crowdsourced images for effective landslide detection with the minimal data set by using a pre-trained mask RCNN model. Now, in my research work, I have used pre-trained mask RCNN model for the landslide detection. The mask RCNN algorithm has been proposed by Facebook AI research team in 2017 by using Python and Cafe2, and it is trained on the MS Coco dataset. The mask RCN algorithm basically focuses on the instance segmentation, and instance segmentation deals with two sub problems, that is object detection and semantic segmentation. From semantic segmentation on the image we get mask, and from the object detection we get the bounding box over the image on the area of interest. And the its architecture is based on the extension of the faster RCNN architecture, and the semantic segmentation is uses the fully convolution network. Now this is the basic architecture of mask CNN algorithm. In this first step, the image is fed into the CNN, that is convolutional neural network, that serve as a feature extractor for extracting the image features. Then CNN region proposal network is used to create region of interest. After that, ROI pooling has been applied to warp them into fixed dimension, or to create the features having fixed dimension. And after that, it is then fed into the fully connected layer to make the classification and bounding box prediction. And in the second step, two convolution layers are added for generating the mask over the image, or to identify the image. This is the basic architecture of mask Carcinian algorithm, and I have used this algorithm on UAV images for to perform the landslide detection. As we know that mass Carcin, as I have already discussed, that mass Carcin is the combination of fast Carcin and FCN, and the dependencies used for the implementation of mass Carcin includes NumPy, SciPy, scikit-image, OpenCV, Python, TensorFlow, and Keras libraries, and Google Colab along with the Jupyter Notebook. For using mass CNN on new dataset, pre-trained weights are used. This algorithm can be used to predict the image. Now, in this slide, here I am going to discuss about the landslide detection methodology which I have adopted in my research work. First, I am proceeding with the first step. And the first step, data collection has been performed. The data set used in this research work, uh, the dataset used in this research work is composed of several images, including high resolution images, mainly acquired by UAVs and freely downloaded from the available search engines, that is Bing and Google, and other sources. Some specific images that belong to the particular terrain having landslides were manually selected by visually analyzing the images. Now, in the second step, data processing have been performed, and after the selection of the images, two pre-processing steps have been adopted, that is resizing the image for reducing the complexity of the resized image. And resized image have the dimension of 512 cross 512 pixels, and image augmentation have been applied by using the image data generator for increasing the number of training images. Now, in the next step, data labeling and annotation have been done in next stage, and four classes are defined, that is landslide, vegetation, water body, background, and VGG image annotator, that is visual graphic group image annotator, has been used to define the regions in an image, or to define the class and to add the textual description of these regions. Now, in the next step, further the data set is divided into the two sets, that is set A and set B. Now, set A is further divided into training images, that is 101, validation images 28, testing 31, and set B is also composed of three folders, that is training images, validation images, and testing images. Training images consist of total number of 62 images, validation folder consists of 28 images, and testing folder consists of total number of 31 images. And after that, deep learning based algorithm, that is Mars-Car-CNN, is utilized with two backbone models, that is ResNet 50 and ResNet 101, and its implementation operates through an open source library to perform the various tasks. In the last step, the model comparison and analysis has been performed by using the different evaluation matrices. Now, this is the architectural description of my proposed work, and in this diagram, in the mass Carson model that uses digital photographs from the created data sets are annotated first, and then it contains the coordinates of the defined class that is generated in the previous step. Now in this algorithm, it is composed of basically two parts. That is, first is the ResNet 50 and 101 convolution backbone architecture for extraction of features from entire image, and in the second part, it is composed of network head used for bounding box prediction, classification, and along followed by the mask prediction, and it is individually applied to each region of interest. In the figure, the input image is passed through the convolution backbone network, that is ResNet 50 and ResNet 101, and the output of first convolution network is downsampled, uh, and pixel value of which is further passed through the region proposal network that creates the distinct anchor boxes, that is ROIs, and depending on the existence of the objects to be detected, the landslide can be predicted. And in the next stage, anchor boxes are proposed by ROA align to protect the spatial orientation by using bilinear interpolation. The main purpose of ROA align is to make all the region of interest of same size for easing the further processing. And the output obtained from the previous layer is sent to the fully connected layer for generating the object class as a result for a specific region along with the bounding box representing the location of the object. In the last step, the output obtained from the ROA line is fed to the convolution layers parallelly intended to the generate a mask of the object. And ROA alignment is unit is used and a fixed size feature map is generated, and which will be used for detecting the landslide regions on the image. And accuracy of the formed regions is determined by the trained transfer learning model. And in the last step, we will get our output. Now this is the simulation result that are obtained, as in table 1 represents the overall loss value that is obtained by ResNet 50 and ResNet 101, and it is found that as the number of epochs increases, the loss value also decreases, and it is gets saturated after 20th epoch. Table 2 represents the correctly predicted positive observation for both ResNets, and out of total samples, the correct prediction by ResNet 50 is 0.87 and by 101 is 93, and the detection accuracy is 0.93 with ResNet 50 and 97 with ResNet 101. Now table 3 and 4 represents the precision recall F1 score values and frames accuracy that are obtained with both backbone models. Now table 5th represents the detection accuracy and objectness scores for ResNet 101. Table 6th and 7th is observed from the tables that the loss value decreases with the increase in the number of epochs, and the average loss values for is 61% for ResNet 50 and 50% with ResNet 101. Now these are my observations from the obtained result, that the overall loss generated for ResNet 50 and 101 after each epoch uh, is represented in the table, and it is observed that overall loss decreases while landslide detection accuracy increases for both backbone networks, that is ResNet 50 and 101. And uh, in the another tables, we can see that with both data sets, that is set A and B, ResNet 101 outperforms that as compared to ResNet 50, and the random frame accuracy reaches to 99%, and for both backbone models, and k-fold cross validation value for both backbone models and has been also analyzed, and it is found that loss value decreases as number of epochs are increasing. Now this is the output obtained from both backbone models. Now this is my publication. Thank you. If any questions, then questions are welcome. Thank you.